Okay, today we are going to add vocab to the solving that we are already doing. All right? I'm going to draw a Venn diagram at the top because I think that is the easiest way to categorize. Right? All right, the left box is smaller than the right box. It's a Venn diagram, but I'm just making mine square. Imaginary? Yeah, why not? It's just where these things overlap or not overlap. Okay, we are classifying solutions. We started using some vocab last week. Today we're going to formalize that vocab and we're going to use it some more. Imaginary numbers have an I. Okay, we have real. Notice that my only two choices are real or imaginary. That's it. Those are the only two choices you get. Now, within the real category, there's a subset. Okay? Okay, subset of choices. I wonder if this would be better if okay, I'm going to do this. I'm going to make this side green so that we can see where okay, there you go, green. We'll make all of the real choices green. Okay. Irrational. And this one, it's one or the other. And I've used these words before, but today we're going to be specific about which numbers fall into which categories. Okay, irrational numbers have a radical. Or we call these non-repeating decimals. For example, pi, root 7. We are going to solve quadratic equations, and then we're also going to use vocabulary words to describe those answers. Okay, rational is the other choice, and this is ratio of integers. Or repeating decimals. Okay, for example, 1 negative 2/3. 0.3 repeating, because 0.3 repeating is really 1/3. Repeating decimals can be written as a ratio of integers, which means fraction. Okay? These are my only choices. Okay. Quadratic. This is more of a vocab day, right? Just defining some things. ax squared plus bx plus c equals 0. Quadratic equation. Notice that the a, b, c, those are the coefficients. It's an equation because it's got an equals. Solutions. The solutions to the quadratic equation come from the quadratic formula. Okay. we're going to define one more thing, and it is the discriminant. Okay. And the discriminant, I'm going to call it D, is just this part right here underneath the radical. That's it. The discriminant, and that's really what our lesson is about today, is just that part right there. Now a quadratic equation, see this degree 2, has two solutions. It always has two solutions because the degree is 2. And we're going to figure out how to categorize those answers using imaginary, real, irrational, and rational. Okay, we're going to solve as we do it. Now I'm going to leave a chart here. Okay, and as we solve our questions, we'll come back and we'll fill in the chart. Our chart needs 4 boxes. You can do the boxes however big you want. They will fit across, okay? 4 boxes. There we go. Okay, and solve. Okay, solve. You are still doing the exact same choice, guys. Isolate, factor, complete the square. Those are your only choices, but today we're going to see how the quadratic formula can be used to help us classify. We are not actually going to use the quadratic formula to solve. Okay, you can use it to check your work, but we're not going to use it as our first choice. Isolate, factor, or complete the square. Well, it's not isolate, and it's not factor. So let's complete the square. Okay. Okay. Set it up. Add your numbers. And keep going. We can do it. Okay, notice that my plus or minus goes in front of the radical portion. Okay, and then we subtract 2. All right, classify your answers. So we're going up to that very first box, and we need to pick our descriptors. I see an I, so I'm going to pick imaginary. Okay, two solutions, and they happen to be imaginary. Notice that in the imaginary box, there's no other vocab choices. That is it. All right, now off to the side here, we're actually going to do the quadratic formula so we can see where these things connect. All right. X equals opposite B plus or minus B squared minus 4AC all over 2A. Now, I prefer to split up my fraction because I find it easier to reduce. Okay, so that's 4i. Yeah, you should get the same answer. That's the whole point. But the quadratic formula is only for checking your work, guys. You should be isolating, factoring, or doing the complete the square. All right, but I want to highlight my discriminant. The discriminant is -16. The discriminant is -16. A negative number went under my radical. What happened to my answers? My answers turned into imaginary numbers. And so our first category is going to be the discriminant less than 0. Now, what happens when you put a negative number under the radical? It turns into 2 imaginary solutions. Okay, so there are 2 solutions. Makes sense? There's supposed to be 2 answers. What kind are they? Imaginary. If the discriminant is negative, I'll put a negative under the radical, and it will give me an imaginary solution. Why are there 2 of them? There's a plus and a minus in front of that radical. Okay, the quadratic formula is for checking. It's not actually the work I would expect to see. Okay, let's do a second question. Right? 4 boxes, 4 questions. Okay. Question 2. All right. Solve x squared plus 6x plus 9 equals 0. Okay, isolate, factor, complete the square. I would factor, okay? X plus 3, x plus 3. I'm picking simple questions, guys, so this part is faster because we're worried about the vocab today. We get x equals -3, x equals -3. Okay, there is one answer. -3 is the only answer. There is one repeated solution. But there is only one number up there, -3. Okay? Right, let's pick our, we counted, right? There's one of them. It is real. Now, in the real box, there's a subcategory. Irrational or rational? Rational. Real, rational. We are trying to be as specific as possible. If you're in the real box, you have to pick a subcategory. All right, do the quadratic formula next to it, and let's see what we get. X equals opposite b plus or minus b squared minus 4ac all over 2a. I get 0. Okay. X equals -3 plus or minus 0. Well, adding and subtracting 0 doesn't actually change anything. So the answer is just -3. Okay, so let's go figure out what our discriminant was. Our discriminant was 0. It's the number that is under, I'm not highlighting the radical, I'm highlighting the number under the radical. So a discriminant of 0 gives me the repeated solution, because there still needs to be two of them, but when I do my quadratic formula, I only get one number, which corresponds to a perfect square trinomial. The discriminant of 0 means the same factor twice. All right, so that's our second box on our chart. Discriminant of 0 is one repeated solution that is real and rational. And then this is what the work looks like that goes with it. Okay, let's fill out the second box. Discriminant 0. 1. You can say repeated or double, and it's real, rational. It's an arrow because rational is underneath of the real category. All right. Almost there. Okay. Third question. Make it fancier. 3x squared minus x minus 2 equals 0. Isolate, factor, or complete the square. I'm going to try factoring. Okay? There are two solutions. All right, I count two of them. Now we categorize them. I don't see any i's, so they are real. I don't see a radical. I see a ratio of integers, so they are rational. All right, let's do your quadratic formula, and let's figure out what our discriminant is and how that gives us these answers here. Okay, careful with this minus minus. It is going to end up being addition. 1, 12, 25. I get positive 25. Okay, my discriminant is 25. It's the number under the radical. Now, when I have a perfect square, what's going to happen to my radical? It's going to simplify completely. When your discriminant is a perfect square, it simplifies completely. No more radical. Okay, we'll finish it. You actually have to add your like terms together. So we're going to get x equals 1 plus 5 over 6 equals 1. Kind of makes sense. I see my 1 over here. Okay. And x equals 1 minus 5 over 6 minus 2/3. Okay, so I did get the same answers. Guys, if you pick the wrong method, do you see how much extra work you have to do? 2 lines versus 6 lines. Make sure you're picking the right method. I wouldn't want to complete the square. It's going to look like as many steps as this. Complete the square / quadratic formula are the same thing. Don't pick it when you don't have to. Okay, so a perfect square. Notice that my discriminant is positive, but it's a perfect square. Your discriminant goes under the radical. What happens when you put a perfect square under the radical? It simplifies to a ratio of integers. Real ratio of integers. Okay, so let's put it in our box. Now I'm going to say the discriminant is positive. Okay? Because it is. But it's got a subcategory of perfect square. Two solutions that are real and rational. Notice how there's only one place on here that's got a 1 repeated. That's it. That's the only place that's got a repeated solution. Right there. Okay. Last example. Last box. All right. Last example. All right, let's see if I can do this. 2x squared minus 8x minus 6. Yeah, minus 6. Okay, let's see what happens now. Isolate, factor, complete the square. Actually, would you be mad if I changed it to something simpler? All right. I'll put the answer up for this one also, but let's do this. 2x squared minus 40 equals 0. Okay. I wanted to pick a different solving method. Do you notice what I changed? It's isolate, just so we had a chance to see that. Yeah, we're going to do this one instead. They would classify the same way. Okay, here we go. I would isolate. Okay, so I'm going to add the 40 and divide the 2. Add the 40, then divide the 2. X squared equals 20. X equals plus or minus 4 times 5, 2 roots of 5. Okay. Well, there's 2 answers. They are real. They are irrational because they are not a ratio of integers. All right. Let's do your quadratic formula. Ooh. The middle term is missing. That makes your b value 0. Plus or minus b squared minus 4ac all over 2a. Okay. 80, 320. My discriminant is 320. I don't know about you, but I don't really want to figure out my perfect squares with 320. Since I already have the answer over here with much smaller numbers. Okay? All over 4. Now I'm assuming that this simplifies because the answer is plus or minus 2 root 5. So my discriminant is positive, but it is not a perfect square. So I have two solutions. They happen to be real, but they also happen to have a radical, which is irrational. Okay, so I'm going to give you your homework, and we're going to do the first... Oh, you already have it? Awesome. Okay. We're going to do the first question together so you know what it should look like, and then we'll play our Kahoot for practice until about 20 minutes left in class. All right, keep your notes out for reference. So we have to fill in our last box. All right, when my discriminant is not a perfect square, not a perfect square, I get two solutions. They are real, but they are irrational. I feel like I need to highlight the things that are the same and the things that are different to make it easier to remember. Two solutions is everywhere except that one spot. Okay? Just looking at the differences. Okay? Yes. Oh, yeah, they were both bigger than 0. They were both positive. If you put a positive number under the radical, you get real. So I feel like I am going to say this. D is more than 0 is where the real part comes in. Helps me organize my thoughts. Okay. Do I have a red marker? Purple. Let's see if we got red. And green. There we go. Okay. Okay. D less than 0 is how I pick imaginary. All right, so we've got D equal to 0 is how I pick real. And then I guess the perfect square is how I pick the other part. Those are the big differences here. And then I always remember radicals for irrational. All right. Here's what your homework should look like. We're going to do the first one together, and then keep your stuff out for reference as we play. Okay. Here we go. Yeah, I'm gonna show you one example from your homework, and then you will play. Okay, number 1. Now you are isolating, factoring, or completing a square. Try factoring. 1 and 3. 3 and 2. Okay. You're still solving. Isolate, factor, complete the square. Those are your only choices. Okay. X equals 1/3. X equals 3/2. It's not written here, but I want you to classify them. Okay, so I have 2 solutions, and they are real and rational. That's what I'm looking for. Actually solve them and tell me about them. There's 2 of them. They're real. They're rational. Yes, but you are also going to find the discriminant so you can see some more of the connections between the discriminant and how the solutions are formed. Okay, so the discriminant is b squared minus 4ac. Not every question is going to say solve. Some of them might actually just say classify. Okay? 121 minus 11 squared. Okay, so the discriminant is 49. Look at what kind of answers you got from a discriminant being 49. A perfect square. Discriminant is 49 means when I put it under the radical, it will simplify completely into real and rational answers.